Hello, everyone, and welcome to a brand new series System Design and Software Architecture from Fundamental to Advanced. So, this series is for developers who can already write code but freeze up the moment they are asked to design real world architecture or face a system design round in an interview. We are starting today with chapter 1 System Design Fundamentals. This chapter is the foundation for everything else in the series. So let's get it right. So before we dive in, let's be clear about what this series actually is. It's built specially for developers who are comfortable writing code but get stuck the moment somebody asks them to design architecture on a whiteboard. We are not just going to memorize buzzwords here. Terms like AWS, Kafka, Kubernetes shouldn't just be name you recall. We are going to understand exactly why these technologies exist in the first place. Our approach is simple. We start with the fundamentals, requirements, scalability, availability. Then we move into databases, caching, and messaging. After that, microservices and full cloud architecture. And towards the end, we will tackle real case studies, a URL, shortener, a Netflix like system, and Uber like system, WhatsApp like system. So, if you want to learn system design properly, step by step, this series is built for exactly that. So let's move to third slide. So, what is system design really? So, let's start with the really important question: what does system design actual mean? So, many people think it's about drawing boxes and arrows on a whiteboard, naming a few trendy tools, Redis, Kafka, Kubernetes, or memorizing one correct architecture diagram. But that's not design, that's decoration. Real system design happens when you start asking questions. How many users will actually hit the system? What happens if a server goes down? Does the result need to be instant, or can it wait? And most important, what's our budget, our timeline, our team size? Every box you draw represents a trade off, never a fixed template. The next slide. So let's understand. And that brings us the core message of the entire chapter, really, of this entire series. System design is not about drawing boxes, it's about making engineering decisions under constraints. Money, time, traffic, team size, failure. These are the walls we are boxed in by, and architecture is simply how we build within those walls. So we will get back to the exact idea again throughout the series. So the next one is, let's understand every great system starts small, and that's very true. So let's actually see how a system evolves. Right from the very beginning, every large complex system starts small, a single application, one code base running on one server. At this stage, there is no scaling problem at all, simply because there's barely any traffic. And this is where every product and every architecture story truly begins. Uh, So add a database, but an application with no memory isn't very useful. So the next step is to add a database. A user signs up, save it, and user places an order, save it, application plus database become the standard two-piece system. This setup works beautifully until real traffic shows up. So now more users arrive and it start breaking. uh, and this is the moment when we will have a million of users and this problem will begin. A single server has a ceiling, limited CPU, limited memory, a limited number of connections. Requests start going up and the response time start climbing. This is the exact moment where real architecture decisions begin. Now we actually have to figure out how do we solve this? So distribute the load. The load balancer sits in front and spreads incoming traffic across multiple identical app servers, app 1, app 2, and more if needed. This is what we call horizontal scaling. Instead of buying one bigger machine, we add several small ones. And the next is introducing caching. So the problem is speed. Not every single request needs to hit the database. So we will introduce a caching layer, something like Redis stores. A cache stores might be hot, frequently accessed data in fast memory. The result, lower latency and far less pressure on the database. So now quiz and asynchronous work. Some work doesn't need to happen instantly. Sending an email, generating a report. For this, B use a queue. The application drop a message into the queue and moves on immediately. The user gets a response right away. In the background, a worker picks up that message and processes it at its own pace. So now let's understand this microservices, which has emerges due to recent cloud technologies. As the product start growing and the team grows along with it, managing one Gantt application becomes really difficult. So that applications start breaking apart into smaller independent services. Think auth service, order service, payment service. Each service is owned by its own small team and deployed on its own, but they all share a common data layer underneath. So everything moves to the cloud. The cloud doesn't introduce any new concept. It simply rents you the infrastructure for everything. We have just built elastic scaling, so you pay only for what you use. Manage databases and queues, global data centers available on demand. This is exactly why AWS, Azure, GCP, Kubernetes, and Kafka exist. They industrialize the entire evolution we just walked through. And now let's look on the complete picture, how a simple app becomes a distributed system. So now let's understand it. We started with a single application, then we added a database, more users arrived, and we hit a bottleneck, a load balancer, and multiple app instances came in. Then we added a caching layer, then queues for asynchronous work, then microservices formed, then everything moved to the cloud, and at the end what we have is a distributed system. Netflix, over WhatsApp, every mature system walked this exact same ladder. So they didn't start out distributed. They became distributed, solving one constraint at a time. This is the mental model that will guide us through the entire series. So next one. So let's summarize chapter 1. First, system design is about decisions, not diagrams, traffic, cost, time, team size. These are the real constraints we make decisions within. Second, there's really just one evolution path, users to app, app to database, then scale, then cloud, then distributed system. Almost every system follows the same path. Third, complexity is earned, load balancers, caches, queues, microservices. Each one is added only when the previous stage hits its limit. And the fourth, tools follows needs. AWS, Kubernetes, Kafka, Redis aren't buzzwords. They are answer to specific predictable problems. So now this is the last slide. In the next chapter, we are going to talk about requirements, functional and non functional requirements, because before we scale everything, we need to know exactly what we are building and what good actually look like for that system. If you found this video helpful, do like it, subscribe to the channel, and drop your questions in the comment below. See you in the next chapter. Thank you for watching.